Rate of change, oh, and this should be V. Carter, you must have been looking at 22. Oh, did I tell you to do 22? Oh, okay, someone else did 23. Okay, well, that's fine. 22. So we're looking at number 22. Well, that happens to be a homework problem, so you're going to get a homework problem done right now. It says the rate of change of n is proportional to n. So how do you write the rate of change of n? dn over, now how do you know it's t? They give you t's. So you know the rate of change of n, you know it's over dt because they give you things like, later in the problem they give you t equals 1, n equals 400. They're telling you an ordered pair, 1 comma 400. And then when it says, what is the value of, oh, then they say when t is 0, n is 250. So that's giving you saying the function also passes through the ordered pair 0, comma 250. They want to know when t equals 4, what is n? So we're trying to actually answer this question right here. We know these are ordered pairs on the function n. And we know that the rate of change of n is proportional to, now what did I say proportional to looked like before? Proportional to means k times whatever it says it's proportional to. A number times something. So k times what? N. So this is our differential equation that we need to integrate both sides. So the n's go over here, t's go over here. So divide by n, multiply by dt. What is the integral of the left? Natural log of the absolute value of n. The integral of the right, k is a number like 73. It's the antiderivative of 73. 73 times t. So the antiderivative is kt plus c. Now here's why you need two initial conditions. Remember, these are called initial conditions. It is so important that you learn this vocabulary: proportional to, inversely proportional to, differential equation, rate of change of, initial condition, particular solution, general solution. And that comes from reading the book. All right? So we need two initial conditions to help us find both constants. Now we're not done. Okay, we want to get n by itself here, so we apply e to both sides. And this side becomes n equals, this e needs to be written as the base of both parts. And what do we write that e to the c as? One big C. So I have n equals c e to the kt power. Now, I actually saw quite a few people that were that far. That's great. Now we need to find what is n when t is 4. Try it. Can you put 4 in for t and get a number out? No, you don't know c or k. So I'm going to find that by putting 1 in for t and 400 in for n. Whoops. Which would just make it 1k. All right. And then 250 equals ce to the 0 power. So c is what? 250. And then can I put 250 in there? And then I'm going to be able to find k. So how am I going to find k? How do you get K by itself here? This is a pre-calculus. Divide by 250. So I've got 400 equals 250 e to the K. Divide by 250. And then do what to both sides? Take the natural log of both sides. And that'll give you K equals whatever the natural log of 400 divided by 250 is. We knew that C was 250. So my final differential equation here, final solution to this is going to be N equals 250 e to the, well, K is this, natural log of, I can simplify that a bit, so that'd be 8 over 5, the natural log of 8/5 times T. Now that is the most exact answer you can get. Exact would not be changing the natural log of 8/5 to a decimal. If you did, that's probably fine. In fact, they probably have that if that were in the back. All right, a couple of formulas you may need to know, and then we'll be done with notes, and you will have about 15 minutes to get started on a couple problems. These are some growth and decay equations. And these are actually, they're also referred to as exponential growth or decay. And basically any equation that would be like of this format, y equals ce to the kt. Okay, K, if negative is decay, if positive is growth. And this is always continuous growth or decay. And this could apply to financial situations. You might see another format of this. A equals PE to the RT power. And this, does anyone know what this has to do with? What area of math is this formula used in with the A and the P? Interest. Okay, P would be the principal amount, the amount of money you put in the bank. A is the final amount you end up with. R is the APR, like the percentage as a decimal. That should be a formula. That was continuous growth. Not every time is interest continuously. So this is just a basic formula for compound interest. And this would be A equals P times, let's see, 1 plus, trying to remember, 1 plus R over N to the NT power, where N is the number of times interest is compounded in a year. So quarterly. What would N be if it was quarterly? If it was monthly, what would N be? 12. And T is time. How long? Like 10 years, 5 years? T is always time in years. So this formula here, back up here, can apply to bacteria. You'll have some problems, 34, 36, and 38, that have to do with half-life. Okay, half-life is really pretty, it's pretty simple. How many of you know what half-life of something is? Describe it to me. Very good. The time it takes to decay, so half of it's left. So if the half-life is 5,000 years, it takes 5,000 years for half of what you started with to be left. So you've got a few problems like that. So don't skip the word problems. They're really just using some of these formulas. So you've got for homework 2 through 38 even, a lot of antiderivatives. Any of you who have taken some chemistry, you've probably done some of the last problems about, did you do half-life stuff in chemistry or not? Is that more physics? No? Chemistry? So there's a few... Biology, okay, so half-life problems. I know we did them in pre-calc a little bit. And then 2 review problems over section 1. One of them is a slope field and the other one is an Euler's method. So